Hi, this presentation is for the 11th International Conference for Internet Technology and Security Transactions. The title of this presentation is Smartphone as Biometric Service for Web Authentication. My name is Alex Orozco. I am Assistant Professor at Sul-Rio Grandense Federal Institute and a doctoral student at Pontifical Catholic University of Rio Grande do Sul. The authors of this work are composed by Régio Michelin, Avelino Zorzo, Márcia Campos, Charles Neu, and me. This is a quick overview related to the topics that we are addressing in this presentation. I will briefly introduce the subject and relate it to the problem that's addressed in this research. Then, I will contextualize with some background acknowledgement that bases our research. I will explain our proposal, architecture, as well as the steps that are involved in this execution. After that, I will talk about the way how the mechanism should be evaluated regarding to usability aspects as well as security approach. Finally, as this research is a work in progress, I will contextualize the status of this proposal implementation and what we are going to do next. Nowadays, almost every single online application requires a way to identify who is accessing. The most common identification applied is the pair user and password. This mechanism would not be a problem if you have to remember just one pair, but it's not what happens in our connected world, where we have several different accounts like email, social networks, e-banking, and so on. Once we need to use our pair user and pass in these websites, we are reusing this password, what's not a good practice. But mostly of websites have a different policy that's applied. It may force the user to choose a different username or create a new password compliant with the site requirements. Due to this need for changes to be compliant with the policies, the user is overwhelmed with multiple passwords. Trying to solve these problems, some approaches that are proposed missing the application's ability. For example, some two-factor authentication that requires the user to receive through email and magic number. For login confirmation, other mechanisms propose to use an additional hardware that randomically generates a one-time pad number to login. When talking about an extra hardware, it's for many times considered a problem that avoids the biometric usage. And considering the biometric as a way to read some human characteristics, these mechanisms could be applied to change the traditional user and password authentication, since through it the user do not need to memorize almost anything. Its biological characteristics are with him for his whole life. Again, the main barrier to the wide biometric adoption is an extra hardware need, which is an inconvenience for majority of users. Thinking to solve these problems of multiple passwords for the user perspective and using the biometric reading for identify the user, it was noted that nowadays most people possess a smartphone, and the modern smartphones are equipped with different kinds of sensors capable of different levels of user reading. With that in mind, the research is going to propose a mechanism able to read biometric information from the user's smartphone sensors and use it to authenticate in a web application. As we researched a way how a user is identified in an application, we read the Meng's research. We've classified the user identification method in what the user know, have, or are. For each one of these methods, we can find a problem related with. For example, the traditional password that we are using to access every single application has a problem that can be shared, and through this impersonating the user. It can also be forgotten, and etc. In a different approach, there is the method that considers what the user have, in which the user must prove that he owns something, for example, a card, key, badge, etc. But a problem related to this method is that it can also be shared and even duplicated, allowing that more than one person possesses the same identification. The last method is to consider the user release. So basically, it reads the user biological information like fingerprinting, palm, iris, face, etc. Since the method reads this information from an user, it will be considered to differentiate between different users. So it will not allow us to share these characteristics, or at least it's very difficult to duplicate this information. Once this is a very personal information, because it's biological information, the user later will not be able to repudiate any information or action that was performed. Once you are going to identify the user based on his biological, we are following biometric taxonomy that divides the biometric traits between physiological and behavioral. As the name states, physiological is the capacity of reading user physical information like face, fingerprint, iris, and hand. These are characteristics that are part of every single user, and its usage as part of identification can be applied to differentiate each user. On the other hand, there are behavior traits, which are bound to each user, but is more linked to the behavior, and at these characteristics are user signature, voice, keystroke, and gait patterns. A problem on these characteristics is that they can be changed even for the own user during the time, so the mechanism should be able to adequate these changes, still recognizing the user. So, we are proposing a method for using the biometric authentication to a web application. In order to avoid an extra hardware need, in our mechanisms, the user on the smartphone is going to act as a biometric reader. As a pre-work step, the user is going to fulfill a sign-up form, and at this point, the user must register his smartphone number, as well performing the biometric read. So, in a further biometric reading, it will match the register patterns with the sample collected. The authentication mechanism starts when the user accesses the web server and asks for access to any protected data. At this point, the server will generate a QR code to be read by the user's smartphone. That way, we try to ensure that the user and his smartphone are next to the web client that are requesting access to the web server. The smartphone will send a list of sensors, and then the server will ask for read some of them. Later, I will explain how it's going to choose a sensor. As authentication mechanism, we define a flow to use following in order to get access to the system. As described in the slide, there are 7 main steps. First of all, the user requests access to a web server. Once this web server identifies the user is valid, it will send back a QR code that's composed by a username, the server timestamp, and a salt that should be read by user's smartphone and sent back to the web server. On this response, the smartphone also sends a list of sensors available like keystroke, signature, voice, fingerprinting, iris, face, etc. The server will choose a biometric sensor based on the information criticality and then asks to the smartphone to perform that biometric reading. Once the biometric info is read, it's sent back to the server, which grants or not the access to information. This table presents the accuracy, user usage, and error probability of each sensor. Based on that, we created the algorithm that will pick the appropriate biometric read, based on the information criticality level. For example, we can note that the gate is one with a low level of accuracy, as well not so easy to use. Then, this biometric reading will be considered only as a last option or for information that does not require a right security. In the other hand, for a high level of security information, we activate the iris biometric read due to its very high accuracy. It's good to talk as well that for each of these traits, on the error we had mapped what are the error codes, so it can be considered to choose a different sensor. For example, if the user is in a very high or very low environment light, they are not activating the iris and face recognition, since these reads are affected by light. To evaluate the authentication method usability, we consider 9 main aspects that are in this slide: efficiency, satisfaction, productivity, learnability, safety, trustfulness, accessibility, universality, and usefulness. These indicators are going to provide to us based on the mechanism report generator, given, for example, the time taken by the user to access the application or the total of authentication errors. Since this is a research in progress, currently we are still finishing the web server implementation algorithms, and once it finishes, we are going to select volunteers to test the application. In order to evaluate the mechanism's efficiency, we are going to measure the false acceptable rate, which is the percentage of impostors incorrectly matched to a valid user biometric, as well as face rejection rate, that is the percentage of incorrectly rejected valid users. Each of volunteers will answer a questionnaire before the test trial, and another questionnaire at the end of tests in order to measure the user expectation achievement. If you have some questions, please contact Regio Michelin. His email is regio.michelin@restinga.ifrs.edu.br. Thank you all.